Alright, so today we're going to have a very brief discussion on how surface area affects pressure, or how much area something is in contact with, and how that affects the sharpness and how hard it will press on something, because that is the key to the word pressure, is press. So, to discuss it first, I want to show you a very quick demonstration. I have very sharp nails. They are extremely sharp, sharper than you would think. I have cut myself on these before. And yet they're not popping the balloon. How can that possibly be the case? Well, the answer is surface area and how it affects pressure. Because if I take just one single nail, it pops the balloon extremely well. So more surface area, and I have that drawn with the balloon down here, more surface area equals less pressure, less pressing, less stabbing. That's kind of a good way to think about pressure, is how much it's being pressed. And if something is pressed too much, it could puncture it, as we see in the second image. With a single nail, all of the force that I was pushing with, and I pushed with the same hardness with many nails versus with just the single nail. I pushed with the same amount of force, but it created more pressure with less surface area. And that's your equation for calculating pressure, is how much force divided by how much area. And usually in America we measure it in pounds of force. Pounds of force divided by square inches of area. So how many pounds are packed into every square inch? So with the balloon, because there were a bunch of tips attached to the end that were in contact with the balloon, the surface area of all of those added up. And it's really, if you add them all up, about the size of a quarter. So it's like trying to pop a balloon with a quarter. It just is not very effective. But when you use a single nail, now you have less surface area, which should indicate more pressure. Which brings me to my second example, which all of you guys can do at home. You can do this with a picture frame, a heavy book, or even your iPads. When I place the book flat across my head, about this much surface area is in contact with my head. So the pain is about a 0, maybe a 1 out of 10. I can feel that there is pressure, but realistically, I feel no pain. However, if I take the same 2-pound picture frame, same force, same weight, because right now there's 2 pounds of force pushing down on my head, but it's spread out over maybe 2 square inches. 2 pounds divided by 2 square inches is 1 pound per square inch. And I will show you that. Keep in mind, our equation is pressure is force divided by area. We have 2 pounds, a 2-pound heavy book or iPad or picture frame. So that's 2 pounds of force divided by 2 square inches. And 2 divided by 2 should give you 1 pound per square inch, or 1 psi. But when we take that same 2 pounds of force and we place it on the corner, now that same 2 pounds of force is spread out over a much smaller surface area. That surface area is not even, let's call it 0.1 square inches, because it is a very, very small surface area. That's not even close to an inch. So I'm going to estimate and call it 0.1 square inches. Plugging this into that same equation, pressure is force divided by area, we still have 2 pounds of force. But now we're dividing it by 0.1 square inches. And either you can do this in your head or you can plug it into a calculator. 2 divided by 0.1, well, now that's going to be 20 pounds per square inch, or 20 psi. So the pressure got so much bigger. I'm hoping that whether you prefer it mathematically or you prefer feeling it for your own self, or rather you prefer thinking about how force and area interact and how that affects the sharpness and pressure and pressing, I'm hoping that you have a better understanding of how surface area affects pressure. Thanks a lot. Bye.